Okay, now we're going to take a look at the properties of multiplication. We'll remember back to the fact that we had properties for addition, and we have some of those same properties with multiplication. Alright, so remember we're talking about whole numbers. So we're talking about the set of numbers 0, 1, 2, 3, 4, and the ellipses, of course, mean, and so on forever. Alright, so we talk about the closure property. And we wonder, is this set of whole numbers closed under the operation of multiplication? Well, let's just think about it. So what if I multiply any two of these numbers together? So let's do 0 times 5. Let's do 12 times 10. Let's do 4 times 6. No matter what I do, I'm always going to get a number that's in this set, right? So I would say that the set of whole numbers is closed under multiplication. Okay? So the closure property is true for addition and multiplication both. Alright? Now let's look at the commutative property. And remember what that prefix means. Commute means to move. Okay? So our commutative property of addition was 2 plus 6 equals 6 plus 2. In other words, the order that I put the numbers when we're doing the same operation of addition doesn't matter. Okay? Now, we remember that commutative did not hold true for subtraction. Okay? Now, does commutative hold true for multiplication? So let's try it out and see. 2 times 6 equals 6 times 2. Is that true? And will it always be true? Yes, it will. It doesn't matter what the order. I can do 2 rows of 6 or 6 rows of 2. But any way I go about it, I'm going to end up with 12 objects. Okay? So the commutative property holds true for multiplication. Now, remember, we're changing the order. And let's look at 3 numbers here just for a minute. Let's do 6. And remember, the raised dot means multiplication too. 6 times 2 times 3 equals 3 times 6 times 2. Alright, so what I'm going to do here, this tells me that I took this whole parentheses, this quantity, and I just switched the order. In other words, the quantities before 3, here are the quantities after 3. So let's just see if it actually is the same thing. So order of operations tells us that we're going to do parentheses first. So 6 times 2, or 6 rows of 2, is 12. And then I have 12 rows of 3, or 3 rows of 12, which would be 36. On the right-hand side, I have 6 rows of 2, which is 12. And then I have 3 rows of 12, which is 36. So it doesn't matter if I have 12 rows of 3 or 3 rows of 12, I still have 36 objects. So the commutative property also holds true for multiplication. Alright, let's think about the associative property. With the associative property of addition, we had 2 plus 3 plus 5 equals 2 plus 3 plus 5. And I associate different numbers together. On the left-hand side, I associate 2 and 3 first. On the right-hand side, I associate 3 and 5 first. So on the left-hand side, when I add here, I get 5. And 5 plus 5 is 10. On the right-hand side, I bring down my 2, do the addition in the parentheses. 3 plus 5 is 8. So I have 2 plus 8 is 10. And that is correct. So the associative property held true for addition. Let's see if it holds true for multiplication. All right, let's just change those to 2 times 3 times 5. And 2 times 3 times 5. Now, remember that we are having the numbers in exactly the same order. So remember that the difference between commutative and associative is here my numbers switch their order. What's first is last over here. Now, with the associative property, I'm just grouping different numbers together, but the order stays the same. So 2 times 3 is 6, and 6 times 5 is 30 on the left-hand side. On the right-hand side, I bring down my 2, and 3 times 5 is 15, and then I have 2 rows of 15, which is also 30, or 6 rows of 5. Okay? So the associative property, this is a model for the associative property of multiplication. So it is true for multiplication. All right, now, we remember from when we did addition that the word identity means cause no change. So what causes no change in multiplication? Okay? So let's see. 5 times something equals 5. So we want that to stay exactly like it is. So the only thing that I could multiply 5 by and have no change occur would be 1. So 5 times 1 is 5. 1 causes no change. So 1 is the multiplication identity, which is also sometimes stated as the multiplicative identity. Depending on your textbook, just like addition and additive, that they may be used interchangeably. So again, the identity causes no change. Okay, now, the zero multiplication property, or the zero property of multiplication, depending again on what textbook that you use. But any way you go about it, it means multiply by 0. Okay? So what happens when we multiply any number by 0? No matter what it is, the multiplication property of 0 tells me that if I multiply any number by 0, my answer is always going to be 0. Or think about this. 5 rows with nothing in them is nothing. 8 rows with nothing in them is nothing. 0 rows of 13 items, 0 rows, that means I have none, is 0. So the 0 multiplication property says that no matter what I multiply by 0, my answer will always be 0. Now, this is my favorite property, the distributive property of multiplication over addition and subtraction. Okay, the distributive property is the only property that has multiple operations in it. Now, the distributive property says, well, you know, I could look at this maybe a different way that might be easier. For example, if I did order of operations, I would have 5 times 3 plus 4 is 7, and 5 times 7 is 35. Okay? But if I apply the distributive property, I'm going to distribute my 5, and a number and a parenthesis side by side mean multiplication. So that means that I'm going to multiply 5 times 3, and I'm going to multiply 5 times 4. And this plus sign in the middle, or the addition sign, tells me that I'm going to find the sum of those. If that were a subtraction sign, then we would be doing subtraction. Now, order of operations says that we multiply first. So 5 times 3 is 15. 5 times 4 is 20. And 15 plus 20 is 35. Okay? Now, likewise, if I looked at 6 times 8 plus 6 times 2, okay? I could look at this and I could say, oh, that would be like 48 plus 12. Now, I could undo, so I'm getting large numbers here, okay? Granted, they're not large numbers, they're not too large to work with, but an easier way might be to undo the distributive property. In other words, go from this part back to this. So 6 is distributed to two things. So I could say, well, 6 is distributed to 8 plus 2. Now, if I look at this, 8 plus 2 is 10. 10 plus 10 times 6 is 60. Okay, that was very quick. Okay, and I could do that because I had 6 in both factors. Okay. So the distributive property of multiplication over addition. Or if I had 5 times the quantity 8 minus 2. So distributive would say 5 times 8 minus 5 times 2. And 5 times 8 is 40 minus 10 is 30. Now, this one would be relatively easy to go ahead and do your parentheses and then do your multiplication. But always remember that when you see something in parentheses like this, or with both factors that are the same, then you can work backwards to your parentheses or remove the parentheses and get two multiplication facts. And that is about multiplication properties.